right. Hello, everybody. So here's a video going over your study guide from yesterday for lessons 1 through 5. Hopefully you've turned it in by now completed. If you have not, well, you can take this opportunity to fill out the study guide and then turn it in after you go over it. But just make sure you do finish it. Okay, so let's start with the first one. Part 1, you had to make some particle drawings, and it asked you to make particle drawings of solids. So this is a particle drawing for solid, and notice that they are all in fixed positions. They are close together. They are in kind of an organized pattern. So this is why solids are very tough and hold up. And so kind of like what we demonstrated in class, you can't push your hand through your table because all of these little particles are really bonded very tightly together. We're showing their speed with one swooshy over a particle. So I only put my swooshies on the very top row of the particles, and that's okay to do. If you only added swooshies to a couple of your particles, that is fine, as long as you only added one whooshy for solids. All right, this is particle drawings for liquid. So let's say in the previous slide, we had a piece of ice and the piece of ice melted and it became water. It became a liquid. This is what the particles might look like in that liquid. They are still close together, but they've lost their bond, their strong attachment to one another. They're still loosely bonded. They're weakly bonded. They glide over one another, which makes them have the ability to flow. And we have two whooshies to show a little bit faster speed. They have more energy at this point as a liquid. So we show two swooshies over some of those particles to show their speed. Okay, so let's say this liquid was evaporating and becoming water vapor, which is a gas. So we would show these particles more spread apart, more spaced out, much more random. They've lost all of their bonding. They are not bonded to one another because they're not close enough to have that bond. In the same space as the liquid and the solid. So if we show, I tried to make the boxes about the same size. We have less particles within that space because those particles are spread out more, and we just don't have enough room with all of the space that's being taken, that's taking up that space, all that empty space between the particles. We just don't have as many particles within the same space as we did the liquids and the solids. All right, so that's gas. All right, part 2. You had to take a look at the chart and go through again all of the investigations that we did. The hot and cold water, this was our observation. We saw that the liquid went up the straw when it was heated. When that flask, that water, that liquid with the green food coloring was heated, we saw that water move up the straw. And then down the straw when it was taken off the heat and it was cooled. Okay. And the explanation is that the particles of the liquid have spread apart as they're heating up. They're trying to become a gas. They're kind of on their way to maybe become a gas. So they started to expand. They started to spread apart from one another as the temperature of that liquid went up. All right, the two blocks, observations were that the blocks each had the same volume. They were both 15.625 cubic centimeters, but they had different masses. The metal one was much heavier, had more mass than the wooden block. Our explanation is that there are more particles in the metal block than the wooden one. Okay, so when something has more particles than something else of the same size, it's going to give it more mass. That also means it's denser, it's more dense. More particles packed in the same space as something else will make it more dense. All right, the three syringes, we're dealing with three different substances. We had sand, we had water, and we had air inside these syringes. We could compress the one with air easily, but we could not compress the syringes filled with sand or water. The explanation is that there are more spaces in between the air particles because of a gas. Gas particles are more spread apart, and that allowed us to squeeze the particles closer together. There are not big spaces in between the particles of solids and liquids. Therefore, we could not push them any closer together than what they already were. They were as tightly packed as they possibly could be within that syringe. The balloon, we blew the balloon up. We added air to it. So we saw that the balloon got bigger. The explanation is that those air particles, as we added more and more air to it, spread far apart, pushed on the sides of the balloon. They spread apart from one another, and all of that air filled the whole space of the balloon. And that just means that the balloon didn't collapse in on itself because all of those air particles are pushing up against one another, as well as the sides of the balloon bouncing off one another within the balloon. And that's causing the pressure inside of the balloon. And it's caused the balloon to expand and stay expanded. All right, the station with colored water. This is the last station. The observations were when we added the food coloring to the water. First, the food coloring sank to the bottom of the beaker, then spread around the beaker, making the water look green. And in a video with Mr. Blackman, he used red food coloring. So in the video, it was red. But in our labs in class, the food coloring was green. So within a couple minutes, all of the water looked green. The particles of the food dye had spread evenly around the water. So the particles of the liquid food coloring, they have freedom to move around, and they moved through the water. Let's go back. Spreading among the water or evenly throughout the water. Okay, this little thing. I don't know if you guys can see the little push play and all that with this. Okay. Anyway, here we go. Part 3. So independent, dependent variables. We're given a statement. A study was done to determine the temperature of the air in an oven and how fast a cake will bake. So we could turn the oven up really high to like 450 degrees Fahrenheit, or we could turn it down really low, 250 degrees Fahrenheit, or anywhere in between. And does that affect the speed at which the cake will bake? So here is a hypothesis. We turn this into an if-then statement. If the temperature of the oven is set high, then the cake will bake faster. So the independent variable, what is it that we're testing? What is it that we could change in each of the setups? We could have one oven set at 250. We could have another oven set at 350. We could have a third oven set at 450. So the temperature of the oven is our independent variable. It's what we're testing, the temperature. The dependent variable is the result or what's the end. So like the temperature of the oven, if it's high, is going to cause the cake to bake faster. So our dependent variable is how fast the cake will take to bake. So your independent variable will always be the if part of the statement, temperature of the oven. The dependent variable is always in the then part of the statement, how fast the cake will bake. Second scenario, a student wanted to test how the mass of a paper airplane affected the distance it would fly. So if it has more mass, will it fly farther? If it has less mass, will it fly less far? Or the opposite, if it has more mass, will it fly less far than if it was less mass? It could go either way, so you would have to test it out. So they added paper clips before each test flight. As each paper clip was added, the plane was tested to determine how far it would fly. So we'll make a hypothesis. If we add 10 paper clips to a paper airplane, then it will fly farther than if we added only 5. Now that's just a hypothesis. So the independent variable is in our if part of the statement, and that's talking about the paper clips. So that would be the amount or number of paper clips. Our dependent variable, the result, is found in the then part of the statement, and that's the distance of how far the plane will fly, or the distance the plane travels. Okay? All right, last one. We have students of different ages were given the same puzzle to assemble. The puzzle assembly time was measured. So we could have a 5-year-old student, we could have a 7-year-old student, we could have a 9-year-old student, we could have an 11-year-old, a 13-year-old, a 15-year-old, and they're all given the same puzzle to assemble. And then they were all timed to see who put their puzzle together. Now, it's not the same puzzle. They're not all working on the same puzzle. They each have their own, but it's the same puzzle because we want to control that variable. All right. So we'll put it into an if-then statement. If two students of different ages assemble a similar puzzle, the same puzzle, then the older student will assemble the puzzle faster than a younger student. Our independent variable, remember, is the if part of the statement. So that would be students that have different ages or age of student. And then our dependent variable is always the then part of the statement. And that would be how fast or the time it takes to assemble the puzzle. All right, that is it. That's the end of your study guide. If you have to make any changes, please do so. Next, you're going to work on a Kahoot. So I have assigned that in Google Classroom. And if you finish that, you can study your study guide. You can go back and use Quizlet to study. You can do the Kahoot, look that over, do that again. And good luck. Don't forget that you do have your test on Wednesday. We'll see you on Wednesday.